So the first thing we're going to do is RF. We're going to set up our matrix, which is going to be 2, 3, 4, and 2, 5, -2, 3, and 0, 1, -5, -2, and -4. And you're going to find your RF, and you're going to get your X, Y, and Z. So X equals Y equals Z equals, and I believe by memory it's 2, 2, and -2, but somebody check it. All right, I'm going to scope out my situation. You can leave these equations exactly how they are, but I notice that there's a naked X right here. And since there is, if I make him the second equation, I can eliminate X's a little bit easier without multiplying two equations. When you guys are multiplying by equations, take the time to write it out spaciously and watch your signs. That's what most of you are making mistakes on. The reason we do RF is so that when we find, let's say, Y equals 2, we can see that it's right and continue. If it's wrong, we look for a mistake so you don't get through 30 minutes of work before you figure out you got it all wrong, okay? So I am going to rewrite this guy where I'm going to put this guy in the middle. So it's going to be 2x plus 3y plus 4z equals 2. And you can do this right off the bat instead of wasting this time. I'm just showing you. 2z equals -4. And then 5x minus 2y plus 3z equals 0. And now we're going to take these two. In order to eliminate the x's, I'm going to multiply the second guy by a -2. And I'm going to have 2x plus 3y plus 4z is the first equation. And then I'm going to have -2x plus 10y plus 4z equals 8. And when I add those two equations together, the x's bite the dust, which is what I want, and I have 13y plus 8z equals 10. Now I have to bring the third equation into the party, so I take second and third, which is the third thing. We have to eliminate the same variable from equations 2 and 3. Well, I'm going to eliminate the x again. In order to do that, I'm going to multiply this second guy by a -5. Everybody see why? Because then it'll be opposite this 5x right here. So I'm going to have -5x plus 25y plus 10z equals 20, and 5x minus 2y plus 3z equals 0. And when I add those together, I get the x's bite the dust, and I get 23y plus 13z equals 20. Now, these two equations right here, this one and this one, had y's and z's. So this ends up being what we did last week for elimination. We're going to put those together. We got 13y plus 8z equals 10, and 23y plus 13z equals 20. And I'm going to say to myself, okay, what do I want to eliminate? I always eliminate the smallest. This is ugly, so I'm going to eliminate the smallest numbers because it will keep it from being too big, but it doesn't really matter. So if I multiply this guy by 13 and this guy by -8, they'll be opposites of, the z's will be opposites of each other. So I have 169y plus 8 times 13, 104z equals 130, and then I have -8 times 23, -184y minus 104z equals -160. Got it? And when I add those together, oh, what am I doing? What am I doing?
-16.
Oh, -160, sorry. When I add those together, I get 169 minus 184, which is -15y equals, these bite the dust, -30. So y equals 2. And I go up here and I look at my 2 and it's good. We're good to go. I got a y equals 2. Now to find the z, you use one of these two equations and plug in that 2. So we're going to do that. We have 13y plus 8z equals 10. 13 times 2 plus 8z equals 10. 26 plus 8z equals 10. 8z equals negative 16. I'm just letting the math take me there. And z equals negative 2. I'll go up here. Looks good to me. Now, all we have to do is find x. So we go to the original equation. 2x, let me change color here. 2x plus 3 times y, which is a 2, plus 4 times z, which is a minus 2, equals 2. So 2x plus 6 minus 8 equals 2. 2x equals, 2x minus 2 equals 2. 2x equals 4. X equals 2. So I got the x. So what we do is we look for all the letters involved. And there's P's, Q's, and R's. And that's the order in which they appear in your alphabet. So you're going to use a little bit of literature and grammar for this. So now we're going to set up our matrix to do our ref. And remember that we have to represent all three letters. So we have a 1 for P, a 0 for Q in that first equation, a 4 for R, and a negative 7. In the second equation, there's a P, there is a Q, but there is no R. And in the third equation, there's no P, there is a Q, there is an R. All right, now we have to have a little bit of a strategy. If you look at the first two equations, they have P's that can be eliminated quite easily. And if I eliminate the P's, I'll end up with R's and Q's left. Do you understand that? And if I end up with R's and Q's left, I can match them up with that last one with R's and Q's and find Q and R the way you did last week. So that's what we're going to do. Is that the only way to do it? No. But that's the easiest way into this problem. So you have to have kind of a strategy. So if I change all of these signs, minus P, plus 3Q, and plus 8, and add those first two equations together, the P's bite the dust, and I have 3Q plus 4R equals 1. So now we're going to put that resulting equation from the first two and mix it with the third one. Now you've used all three of your equations, which is, you have to use all three of your equations. You cannot not use that. At some point, you have to use everybody. So now let's eliminate the Q. It's probably the easiest. So we're going to multiply this guy by negative 3. Everybody see that? And we'll have 3Q plus 4R equals 1 up on the first one. The second will be minus 3Q minus 3R equals minus 3. When we add them together, Q's bite the dust, R equals negative 2. So far, so good. We're good. Take that R and plug it into either one of these. And we get 3Q plus 4 times negative 2 equals 1. 3Q minus 8 equals 1. 3Q equals 9. Q equals 3. Looks good to me. Got two of them. And now we've got to plug in the R or the Q into one of those two first equations. Does it matter? No, it does not. We got to find P. So P plus 4R, so it's 4 times negative 2 equals negative 7. P minus 8 equals negative 7. P equals 1. Got it.
So you can use the equation